Namaste students. Today we are going to discuss about lenses. Lens is an optically transparent medium bounded by two spherical refracting surfaces or one plane and one spherical surface. That means two spherical refracting surface or one side is plane and another side is one spherical surface. Okay. Lens is basically classified into two types. They are concave lens and convex lens. Convex lens or biconvex lens. It is a lens bounded by two spherical surfaces such that it is thicker at the center than at the edges. That means center part is thicker than at the edges. It is also called as converging lens because a beam of light passing through it is converged to a point. That means all the light rays are combined together at a single point. Concave lens. Concave lens bounded by two spherical surfaces such that it is thinner at the center than at the edges. That means center part is thinner. It is also called as diverging lens because a parallel beam of light passing through it is diverged or spread out. Okay, concave lens or biconcave lens. Other type of lenses: plano-concave lens, plano-convex lens. If one of the faces of a biconvex lens is plane, it is known as plano-convex lens. One of the faces of a biconvex lens is plane. It is known as plano-convex lens. Plano-concave lens means if one of the faces of a biconcave lens is plane, it is known as plano-concave lens. Image formation. When an object is placed in front of a lens, that concave lens and convex lens, the light rays from the object fall on the lens. The position, size and nature of the image formed can be understood only we know some basic rule. Before going to see the rule, you have to know some terms. Okay. Optical center. Center point of the lens is called optical center. Center of curvature. Center of the sphere of which two spherical surface of a lens. Principal axis. Imaginary straight line passing through the center of curvature. Principal focus. Incident rays parallel to the principal axis. Focal length. Distance between optical center and principal focus. These are the terms you have learnt in lower classes. Let us see the rules of the image formation. First rule: when a ray of light strikes the convex or concave lens obliquely at its optical center, it continues to follow its path without any deviation. Here O is the optical center, F is the principal focus. Okay, when ray of light strikes the convex or concave lens obliquely at optical center, it continuously to follow its path without any deviation. Second rule: when rays are parallel to principal axis strikes a convex or concave lens, the refracted rays are converged to or appear to diverge from the principal focus. Okay. Rule 3: when a ray passing through or directed towards the principal focus strikes a convex or concave lens, the refracted ray will be parallel to the principal axis. Here F1, F2 is the principal focus, O is the optical center. Refraction through a convex lens. Let us discuss the image formation by convex lens when the object is placed at various positions. First one, object at infinity. When an object is placed at infinity, a real image is formed at the principal focus. The size of the image is smaller than the object. Here AB is the object object is placed at infinity, the real image is formed. Real image means image can be captured on the screen, that is real image. So real image is formed in the principal focus. Size of the image is smaller than the object. Next, object placed beyond C. When an object is placed behind the center of curvature, behind the center of curvature, real and inverted image is formed between center of curvature and principal focus. Here A, B is the object, A dash, B dash is the image. Real and inverted image. Okay, the size of the image is same as the object. Object placed at C. When an object is placed at the center of curvature, a real and inverted image is formed. Here AB is the object, A dash, B dash is the inverted and real image. Okay, so when an object is placed at the center of curvature, real and inverted image is formed. Size of the image is same as the object. AB is the image, AB is the object, A dash, B dash is the image. Next one, object placed between F and C. When an object is placed between principal focus and center of curvature, real and inverted image is formed behind the center of curvature. Then size of the image bigger than the object. AB is the object, A dash, B dash is the image. Object placed at the principal focus F. When an object is placed at the principal focus, real image formed at infinity. Real image is formed at infinity. Okay, the size of the image is much larger than the object. AB is the object, but image is formed at infinity. So size of the image is much larger than the object. Next, object placed between principal focus and optic center O. When an object is placed in between F and O, that means principal focus and optical center, virtual image is formed. Virtual image is formed. Dotted lines is the virtual image. Virtual image means image cannot be captured on the screen. Virtual image. Size of the image is larger than the object. AB is the object, A dash, B dash is the image. Application of convex lens. Convex lenses are used as camera lenses. They are used as magnifying lenses. They are used in making microscope, telescope and slide projectors. They are used to correct the defect of vision called hypermetropia. Hypermetropia means is a long-sightedness. Long distance object can see clearly, but short distance object cannot see clearly. Next one, refraction through a concave lens. Let us discuss the formation of images by a concave lens when the object is placed at two possible positions. Convex lens 6 possible position, but concave lens only 2 possible position. First one, object at infinity. When an object is placed at infinity, virtual image is formed at the principal focus. Size of the image is smaller than the object. Object is placed at infinity, virtual image is formed. Here F1 is the principal focus. The dotted lines know that is image formation. Size of the image is smaller than the object. Object at a finite distance. When an object is placed at a finite distance from the lens, virtual image is formed between optic center and principal focus. Here A, B is the object, A1, B1 is the image. So size of the image is smaller than the object. Next, variation in position and size of the object. The distance between the object and the lens decrease. The distance between the image and the lens also decreasing. Here red color lines is the object. Black color line, black color arrow mark is the image. The distance between the object and the lens decreased. The distance between the image and the lens also decrease. Okay, if the distance between the object and the lens is decreased, means the size of the image also increases. Size of the image increases. Okay, clear? Next, application of concave lens. Concave lens are used eye lens of a Galilean telescope. Galilean telescope means instrument for viewing distant object. They are used in wide angle spy hole in door cameras. That means indoors. They are used to correct the defect of vision called myopia. Myopia means short-sightedness. Lens formula. The lens formula gives the relationship among distance of the object, distance of the image and focal length of the lens. The formula 1 by f is equal to 1 by v minus 1 by u. The relationship among distance of the object, distance of the image and focal length. F is the focal length, v is the image distance of the image, u is the distance of the object. This formula applicable for convex and concave lens. Sign convention. Cartesian sign convention are used for measuring various distance in the ray diagrams of spherical lens. There are 6 points is there. First one, the object is always placed on the left side of the lens. The object is placed always in the left side of the lens. Next point, all the distance are measured from the optic center of the lens. All the distance are measured from the optic center of the lens. The third point, the distance measured in the same direction as that of incident light are taken as positive. That means along the incident light, are taken as a positive distance. The distance measured against the direction of incident light are taken as a negative. That means against the incident light we are taken as a negative distance. The distance measured upward and perpendicular to the principal axis, it is taken as a positive. Upward and perpendicular to the principal axis, it is taken as a positive. Then downward and perpendicular to the principal axis, it is taken as a negative. Clear? Magnification of a lens. Magnification of a lens defined ratio of the height of the image to the height of an object. It is denoted by m is equal to h dash divided by h. Also it is related to the distance of the object and distance of the image. M is equal to distance of the image divided by distance of the object is equal to v by u. If the magnification greater than 1, we get an enlarged image, that means a big size image. Less than 1 means we get diminished image, very small image. If the magnification greater than 1, we get an enlarged image. Less than 1, we get diminished image. Lens maker formula. The lens formula relates the focal length of a lens with the distance of object and image. 1 by f is equal to mu minus 1 divided by r1 minus 1 divided by r2. This is the lens maker formula. Mu is the refractive index of the material of the lens. R1 and R2 are the radii of curvature of the two faces of the lens. F is the focal length of the lens. Okay, the lens formula and the lens maker formula are only applicable for thin lenses. Power of a lens. The power of a lens can be defined as the degree of convergence or divergence of light rays. The power of a lens can be defined as the degree of convergence or divergence of light rays. P is equal to 1 by f. When a ray of light falls on a lens, the ability to converge or diverge their light rays depends on the focal length of the lens. That's why P is equal to 1 by f. The power of a lens is numerically defined the reciprocal of its focal length. We also defined as the reciprocal of its focal length. The SI unit of power of a lens is dioptry, denoted as capital D. By sign convention, power of the convex lens taken as a positive, power of a concave lens taken as a negative. Difference between a convex and concave lens. A convex lens, a middle part is thicker, concave lens, middle part is thinner. Convex lens, converging lens, concave lens, diverging lens. Convex lens, mostly real images formed, then concave lens, mostly virtual images. Then convex lens, it is used to treat a hypermetropia. Concave lens, it is used to treat myopia. Then related problem, a beam of light passing through a diverging lens of a focal length 0.3 meter appear to be focused at a distance 0.2 meter behind the lens. Find the position of the object. Okay, so diverging lens means the values we taken as a minus, because diverging lens is a concave lens. Concave lens the is taken as a negative value. So F is equal to minus 0.3 meter, V is equal to minus 0.2 meter. Formula, lens formula, 1 by F is equal to 1 by V minus 1 by U. We need 1 by U. 1 by U is equal to 1 by V minus 1 by F. Okay, substitute all the values. We have to calculate and get the value. 1 by U is equal to minus 10 divided by 6. Reciprocal, U is equal to minus 6 divided by 10 is equal to minus 0.6 meter. This is the position of the object. This value is position of the object. Points to remember. So what are the points we have covered in this session? First one, types of lenses. There are two types of lenses, concave lens and convex lens. Image formed due to refraction through concave and convex lens. Convex lens 6 positions and concave lens 2 positions are there. Application of concave lens and convex lens. Lens formula, 1 by F is equal to 1 by V minus 1 by U. Sign convention, there are 6 Cartesian sign convention is there. Magnification of a lens, M is equal to H dash divided by H. Lens maker formula, 1 by F is equal to mu minus 1, 1 divided by R1 minus 1 divided by R2. Power of a lens, P is equal to 1 by F. Then difference between concave and convex lens. Thank you, students.